Okay, so welcome to week 2 of our remote learning. This is the week of April 1st through the 8th. I'll go ahead and remove this because we are showing to you this a little bit live here early. So for this week, you will be reading pages 548 to 555, and you're going to be answering questions on Schoology about the reading. So I don't care. I signed this to you digitally. So you'll, just like you did last week, you'll sign in to Science Fusion using the Worthington portal. And you'll read these pages. They've been assigned to you. Here they are. Look like this. And once you have read these pages, you will go through and you'll be answering some questions on Schoology. Now, the questions do come from this page, 555. I kind of consolidated them a little bit. But you will go back to the Schoology page once you've read. We're going to go down here to this. Schoology's been doing this. So if you guys run into this, just be patient. We're all experiencing it. So, okay, so you're going to go through and take a look at this quiz. And the quiz has a few questions in there that come from that page. You're going to answer those questions on Schoology and submit them. Once you've done that, the next thing that you have to do is try this digital breakout. Okay, now this digital breakout is a lot like the Marlowe's game that we did, although it's more specific about the content. So it's specifically about potential and kinetic energy. So to do this breakout, you're going to go back to the Schoology page here, and you're going to sign up for a breakout account. And you can see the steps are here. So you're going to go to student.breakoutedu.com, and you're going to click to sign up here link. And you're going to sign up with a new Breakout EDU account right here. So you're going to click sign up. You're going to put in your information. I would just use your school information, your school username, and your school password. And then you're going to be prompted to enter our class code, which is right here, QIBC66. And then once you're signed up, you'll see this page. You'll see your class here. And if you click that, the game will be there. Okay. Now the game is, it's all digital. It's kind of cool. But you will be tasked to complete some, here's my sample account. Sorry, let me log back in here. So you're going to click on this, and here it is. It's called Camp Adventure. So you're going to play this game, and you can work on this with a partner. I think it'd be cool if you guys did something like via FaceTime or something like that. But you're going to go through and you're going to click these locks. So this box, this is the box here. You have 4 different locks. You have 2 numbers and 2 color locks. And you're going to click the first one. And you can see there's a little prompt here. And it says, Camp Adventure hosts a bike race each year. The campers learned kinetic energy is always changing during these races. There's an image. So you can click on this to see, okay, what's going on here. So you're going to look at this, and this is the clue to enter into a 4-digit combination lock. And just click the numbers, and if that's it, you click submit. That, of course, is wrong, so you clear out, back down, and try again. Okay, so there's several different locks here. I will say there's a little bit more about potential and kinetic energy that I think will be helpful that I want to show you and talk about as you guys work on this, okay? So the first thing is, to solve potential and kinetic energy, you're going to use these equations. So kinetic energy is half of the mass times the velocity squared. So half of the mass times velocity squared. So if I go back to my breakout game and I look at my picture, I can see I've got masses down here in kilograms, and I have velocities up here at meters per second. So to solve the kinetic energy of this biker right here, I would take half of his mass, right? And then I would, which is 7, and I would multiply it by this velocity squared, which 4 squared is 16. So I would go through and figure out what that is. So I would do 7 times 16, which is half the mass times velocity squared. And I would write that number down, and I would think about how I might want to use that to solve this lock. I don't want to give too much more away about that. The potential energy, on the other hand, is, and you probably read about this, is the mass times the gravity times the height. So that's, pretty simple. So another way to look at this is kinetic energy is associated with mass and speed, while potential energy is attributed to the mass and the position. And if we look at our biking example specifically here, let's see if I can pull this up. They go together. So as I go up this hill as the biker, I'm putting in energy. I have kinetic energy at the top of this hill. I might not be moving here, so my kinetic energy has changed into potential. And then as I go down, I'm going to transfer that potential energy back into kinetic. Okay, so they can work together, and sometimes you have a blend of both. You have some potential and some kinetic, and blending those is going to be important later when you solve another part of this breakout. So let's see if I can go back here to another lock. Let's see. So if I go to a color lock here, you can see, okay, there's several slides here. They're shuffling through, so I want to see, okay, I've got this, and this, and this, and this. And this is all about potential energy. So I'm going to think about the potential energy. Remember, that's about position and mass. And then the next one is the, it's another color lock. It doesn't let me go back. Let's see, to keep doing this. And now it's about this changing over time here. So how potential energy and kinetic energy change over time. And I'm going to start here, and I'm going to work my way down and think about how potential and kinetic energy have changed. Now remember, with conservation of energy, I'm not losing or gaining any. It's just transferring from one kind to the other. And you can assume I'm starting here. So that would be helpful. And then I'll let you guys kind of figure out the rest. Okay, so that's a little a brief overview here. You can use this image as well, right? So think about like that golf ball, like a roller coaster, moving down. So I start and transfer my potential into kinetic and kinetic to potential, and back and forth, right? So think about that. See if you guys can use a partner via FaceTime or something to work on these together. Of course, you don't have to have a partner. You can do it individually. And that's it. So that's your assignment for the week. Just the reading and the questions, and then the digital breakout. If you need help or have questions, I have 2 office hours on Wednesday, 10 a.m. and 2 p.m. via Zoom. And you can join me at those times. All right, thanks. Have a great week.